Okay, so those first two were things that really you can only do with terrain. Next, what we're going to do is actually what is called a local raster analysis. And this is based on a logical based system, right? So a logic based system being if this, then this, right? And so in this case, one of the most common things to do in a logic based system is to do what's called reclassify. So reclassify basically gives it the if else in the form of a table. So what I'm going to do is I'm going to put in the 2012 data for this. So this is what we've been working with on the previous three. You're going to repeat those processes with the 2020, take a look at them. And so then you're going to say, what am I going to reclassify? Now, more or less the only thing that you can actually reclassify is the values of this. There is no attribute table that is attached to something like this. So the attribute table doesn't exist. So you can't reclassify it by field more or less. So in this particular case, we're going to reclassify it by the value. So reminding ourselves what the value is, we have these values here, right? So this is -3 equals 0, or sorry, that value equals -3.99999 meters. Right, if I go somewhere over here, then we wait for it to do that, we will end up with a value that is 2.97.0092 meters, okay? So what we're gonna do is we're gonna reclassify these. So the first thing we're gonna do is we're gonna hit classify and we're gonna give it a value of 2. So you have to wait a moment oftentimes to do stuff, but then it's going to, this natural breaks is going to give you this histogram where it's going to try and find essentially what this optimal break is, right? Where is there the biggest difference between things? Where can we do that? So it's going to do that. But in this particular case, we're not interested in what it considers to be essentially the statistical break in this case, or the statistical, it makes sense to. In this case, what we want is we are going to want to do the emission scenario, right? So the first scenario that we're going to do is the low emission scenario. And so the low emission scenario says that water is going to rise by 0.7. That's when it's going to rise by the year 2100. And so this is going to be our first one. So this is how much water, assuming that we don't do anything with it, this is how much as of 2012, right? This is where the water would have gotten to by 2100, assuming 0.7 meters of sea level rise. And so once I hit OK, you can see that it auto populates a couple of things. So it gives me the -15.38. This is going to be the lowest value. And then it goes 0.7, what we changed it to. And then it goes 4.974867. This is going to be the high value for this particular thing. You don't want to change this because then if you change this lower, it won't reclassify things as well. So it will continue to have extra values that are no longer 1 and 2. Okay. Now you can change this value to 1 and no data, 1 and 0, keep it as 1 and 2. It doesn't really matter as long as you remember what those values are. With it, which this case is 1 is going to end up what would be below sea level as of 2100. So everything less than 0.7, right? So that would be what would be below sea level as of then. And then this would be all the things that are above sea level. And so here, what we're going to do is we're then going to give this a name that we are going to remember. So this is the low emission scenario for 2012. Now you're going to be repeating this process 6 times. So you're going to do this for 0.7, 1.0, and 1.5 meters to get the low, mid, and high emission scenarios for the 2012 data. And then you're going to be repeating this for the 2020 data. So here we go. And we can also say change missing values to no data. This just means that if it's anything outside of the values that we have listed here, it's just going to automatically change it to no data. This is just a good idea in case you do end up buggering something up on the low or the high end and it doesn't see those as separate things. So now we're going to run this and we are going to see what this does. But what we'll be able to see is that individually, so each one of these values, it is going to logically test this. Is this value between -15 and 0.7? If yes, the new value will be 1. If it's not, if it's above 0.7 meters, then the new value will be 2. And if it falls into neither of those categories based on this, so change the missing values to no data, then it is going to adjust that to be, okay, we are going to have no data values there. So what we can see here is 1. So everything in the green now, right? All of this green is going to be underwater compared to in 2021, right? So everything in that, so we can see out in the Gulf, obviously, but then we can see it filtering in through all of these areas where this is going to flood over the river, where it's going to flood through this, it's going to break over those areas, right? And it's going to continue up those ways. Now, one of the things with this is that obviously you can see in some of these cases right here, they're not actually directly attached to a riverbed. And so it is one of the pitfalls of using this type of thing is that there's no spatial connection to this. So this is where you might then adjust some of the things that you're working with, take a look at where the river is, and then be like, okay, well, if it is not currently touching one of these riverbeds, then it's not going to flood necessarily. But near the coast with such a high water table at that point, it is still possible that as water rises, that's going to rise through these low-lying areas a little bit further in. And so that is also possible. So now what we're going to do is we're going to change this out for the mid emission scenario. So in this case, I'm going to change the midline values to 1.0. So I do have to change the end value and the start value between these two classes to be the same one. So they were originally both 0.7. Now I have to change them both to 1.0. Now this is for the mid emission scenario. And then I'm just going to run this one again. So what this has done is instead of going through the logical test of asking whether or not these values are below 0.7, now it's going to ask whether or not those values are below 1 and give us these new 1, 2 values based on that. So now I'm going to run this and we're going to see how this changes things. But in theory, what you'll see is that more of this area is going to be listed as 1, which would be under sea level in the future. And so we're going to take a look and see which ones of those are, or in which of those scenarios that is true. So now you can see that we have a much stronger section where it is actually this 1 value. So if we go back, right, we originally had all of this area in here that might still be above sea level. And now in the 1.0 scenario, now much of that has gone underwater now. So we only really have a couple of small little islands in that case under the mid emission scenario that will end up be remaining above water. Now we're going to do this again for the high emission scenario. And this means we change out both of those and we change out. Now you'll notice here, I have 1.5 and 1. It didn't actually keep this 1.5 until I do that. And now it's fine. And so this one is the high emission scenario for 2012. So this is the high emission scenario. Going to change that out, going to run that. And once again, we should find that we end up with even more of this area that is going to be listed as underwater in this case. And so again, this is just a what if scenario, right? So this is what if there were no adjustments, we didn't build levees, all of those sorts of things, how much land would end up underwater based on solely the elevation. And so this is something that you will see commonly, and you will see different types of organizations do this. Okay, so now if we take a look at this, we do see that much of this ends up being fairly similar in scope. We do see a little bit of increase in some of the areas like on the edges, and we do see a little bit more cleaning up of this middle section in here, but largely in this area, there isn't too much that is going to change. Now, one of the things that's important in this particular case, if you want to show all of these one on top of each other, is that you're going to have to, 1, layer them correctly, and 2, make sure that you can see through certain things. So if I'm thinking about this, right, and I look at this, if I want to see the larger areas underneath it and I want to see the smaller areas over top of it, I have to make sure that these are layered correctly. So in this case, I have to layer it low emission scenario, mid emission scenario, and high emission scenario. Why? Because this one, the low emission scenario, is going to have the smallest area that is going to remain underwater. It just is. And what I'm then going to do is I'm going to want to make sure that this number 2, I no longer have a color for, so that I can see through it, right? Because if I want to see all of these things one on top of each other, I'm going to want to be able to see through at least part of it. So then if I turn on the mid emission scenario underneath it, we can see in some of these areas, particularly in the center bit over here, we still have this 1. And so then with the purple, we're going to get rid of that 1 too by going to the symbology and changing that to no color. And so now we can see that we've got the green, and now we can see that we've got this kind of blue. This one is the 2100 mid emission scenario. And then we do the same thing. We turn on the high emission scenario, right? We can see the purple is kind of showing through here. We go to 2, we go to the symbology, we turn that into no color, and then we can see that we've got the purple, the blue, and the green to show that. Now, if you want to change those colors so they make a little bit more sense, you can do that over in the symbology as well, right? So I can go over to the symbology and I can say, you know, what do I want for my different symbology, right? So I can click on 1 in this case, and I can say I want this to be blue, right? I can go to the high emission scenario, and instead of it being purple, I want this to be dark blue, right? And then for this high emission scenario, it's got some funky things going on here, but we just changed these values into this light one. And so now we have, in this case, we've got the light, the mid, and the dark coming all the way through. And so this is why we want to have them in this order. If instead we had the high emission scenario over top of it, we know that there's going to be the most area in the high emission scenario that is underwater. And so you won't be able to see anything underneath it. You just won't. So you need to make sure that that's the one below. Now, if you wanted to have just where is water level currently, this one you can do by going to your 2012 one, and you're going to want to pull this up over top of it. Now, currently it's listed under stretch. You can do this by classify, which works essentially the exact same way that classify does for vectors. You switch this to 2, you change this upper value to 0. That would be where current water value is. Change everything above to nothing. And here you go. So now you've got the yellow, which is where water currently is. And you might want to change that to something that actually looks, you know, better. So something like white or black, something in the grayscale is probably fine. And then from there, you've got your emission scenarios going out from there. And so then really, if you're looking at this, right? So if I go over and I take a look at, I don't know, we can take a look at Biloxi, right? And see how much of Biloxi is going to end up compared to where it is currently, right? So you can see that while there's not a ton necessarily in all of Biloxi that's going to go, you do see kind of this mid area that might end up with some issues attached to it, right? So you can take a look here, and you do have, it is mostly, in this case, some sort of marshland wetland style thing, right? So under that scenario there, you can see, okay, well, how much of that is going to go, right? So pretty much as soon as this goes, as soon as water levels rise, many of those areas which historically would have been, you know, some sort of marshland are probably going to go away. You can see that some of the beach is going to go in. And then you can see some of the areas headed into a couple of the different subdivisions might end up with a little bit of area that is lost to them. In particular, you can see this offshoot here over in the Gulf Park Estates, which might end up with some issues, but really it's not nearly as bad as over in some of the Pascagoula areas. So this is just how you can do that. Now you're going to want to repeat this for the 2020 version of this. You're probably going to want to put them in a second map, right? So you're going to want to go over to insert new map. This means that you'll be able to do side-by-sides, right? And you'll be able to pull in your 2021. I can copy this one over into my map over here and repeat that same process for the 2020 map, right? And so that we can see whether or not the 2020 or the 2012 ones we trust a little bit more. So this is a local version of it. So this is a local raster one. Now from there, you can also do things like adjust that by I don't know, take a look at it in comparison to something like the land cover type, see how much urban area is going to be lost in each of these areas, those sorts of things. So this is what you're going to want to do, and then you're going to want to create that map that shows both of these two things together. If you have them under the same symbology, right? So if you have the same symbology in both, then you only need one legend. Make sure you give it a good legend, make sure you give it a good title, and make sure you zoom in on an area, right? So it's pretty hard to see what this is going to what this looks like, right? So make sure that you zoom into an area that actually shows something kind of good and useful to you, right? Where you can see all three different areas, right? Doesn't necessarily have to be the same area as the person beside you, but find a good area where you can see all the different things and where there might be some difference between the 2020 map and the 2012 map. And then also take a look and think about why those might be different between the 2012 map and the 2020 map. So this is some things you can do with your land cover stuff and with your land cover scenario. And you can also add in things like your slope and your hill shade, and you can also take a look and you can play around with, you know, your transparency over here, right? So that you get kind of a cool effect going on about what's land and what's not, all those sorts of things, so that it kind of looks like it's draped over what the landscape might look like. So those are some things you can take a look at and do. Feel free to play around with it and see if you can get something that looks kind of interesting and cool, and so that you can see what's kind of what is going on underneath it as well. So that's all I've got for you. And yeah, how much area is going to be lost to sea level rise?